So the problem we're going to work on here is prove that the limit as x approaches 0 of this function is equal to 0. So the way we're going to work this out is actually very simple, is we let z equal pi over x. Okay, so this pi over x term here, we'll just call it z. Then we have x is equal to pi over z, which means that the square root of x is equal to the square root of pi divided by the square root of z. Okay, so if we make these substitutions, then our limit becomes the limit as z approaches infinity, right? Because as x approaches 0, z approaches infinity. So we have the limit as z approaches infinity of the square root of x. The square root of x is just square root of pi over square root of z. So the square root of pi over square root of z multiplied by e to the sine pi over x. But pi over x is z, so e to the sine of z. So what we're really doing is taking the limit as z approaches infinity of this over here, and that's just going to be the limit as z approaches infinity of the square root of pi times e to the sine of z divided by the square root of z. Okay, so since the sine term in the exponent is periodic, right? It doesn't grow arbitrarily, it's just periodic. That means that this e term here is just going to oscillate. But z is approaching infinity, so the denominator is going to get arbitrarily large, which means this overall term here is going to approach 0. So the limit as z approaches infinity of this term is equal to 0, which proves that the limit as x approaches 0 of root x e to the sine pi over x is equal to 0.